The world is going electric. It's not up for dispute or discussion, it's simply happening. Because it has to. Our reliance on traditional fossil fuels is not sustainable on any level. So not surprisingly, governments and industries around the world have turned to electrification as the path forward. And in doing so have identified that our electric future relies on one key element, nickel. Just how important is nickel? Elon Musk will tell you.
Any mining companies out there, please mine more nickel. Okay. Go for efficient, us environmentally friendly nickel mining at high volume. Tesla will give you a giant contract for a long period of time if you mine nickel efficiently and in an environmentally sensitive way. Hopefully this message goes out to all mining companies. Please get nickel.
Musk is not alone in stressing the importance of nickel supply. He just happens to be one of the loudest and richest with the largest EV stake, so he gets a bit more attention. But while nickel is being positioned as the net zero hero for our electric revolution, Musk and others are quick to point out it also represents electrification's biggest obstacle. Because as good as nickel is, we just can't seem to get enough of it. Despite nickel being the fifth most abundant element on Earth and the second most abundant in the Earth's inner core, supplies are still falling well short of demand. So maybe the key to our electric future is not nickel itself, but more how we gain access to it. Or more specifically, the real key is how we mine nickel. There are a number of potential environmental impacts associated with nickel mining, all of which raise a pretty obvious concern. Clean energy only works if the batteries that produce the clean power are actually clean. We need to be careful and responsible in our pursuit of nickel and electrification. We need to be more aware. This is where the charge comes in. In this podcast series, we'll pull back the curtain on the electric revolution and put the spotlight on its unsung hero, nickel. We'll look at what is nickel and why should we all be loving it a little bit more. Why is it so important for the world's electrification ambitions? What are the potential issues and dangers with mining, and what are the opportunities? And from an investment standpoint, how do we spot potential winners and pretenders? The charge for clean nickel and electrification is on. Time for us to get on board. Let's get started with a quick trip to class, Nickel 101. Because if nickel is truly the key to our cleaner future, it deserves a few minutes of getting to know you. So where are we in the research and development of atomic number 28? Well, we know this. There is an overwhelming amount of interest and activity related to nickel. In fact, Roskill, the leader in critical materials supply chain intelligence, reported that, since 2017, more than 1.3 million patent records mention a relation to lithium-ion batteries, a technology that is heavily based in nickel. So the question begs, when it comes to electrification and battery technologies, why nickel? What makes it so special? That's the question I asked Ken Regisella, mechanical engineer and the program manager for batteries at the Nickel Institute.
The main reason is because it is has the highest energy density of any practical material that can be used. That's really the reason why. And energy density means, range on your car. Secondly, it cycles really well, has relatively good rate capability. And what that means is that in an EV, it translates to acceleration. So when you step on the accelerator, nickel is capable of producing very high rates of discharge.
When I say battery chemistries, what exactly am I talking about when I'm asking that question? Like, what is that chemistry or involved in it?
Most batteries today are lithium-ion. Whether it's in your cell phone, your laptop, or EVs, it's lithium-ion. And there's really two main fundamental chemistries, and they really relate to the cathode. And you have two main segments. You have nickel-based, which today always has cobalt. The other main lithium-ion is what's called LFP, or lithium iron phosphate. Those are the two main technologies. So when you talk about chemistry, when you talk about the lithium-ion chemistry, it's fundamentally always talking about the cathode differences.
In the world of lithium-ion batteries, there are clearly options to be had, which also means there are choices to be made. So, in the spirit of Nobel Prize-winning physicist John B. Goodenough, who is responsible for major breakthroughs in developing stable lithium-ion cathodes, what constitutes a good choice versus just good enough? Let's ask Ken. There seems to be a number of factors to consider when it comes to batteries, especially for EVs. So, what's the deciding factor in choosing a technology, And how does nickel measure up?
There's a number of metrics that are important in EVs. Number one is cost, of course. Cost trumps everything. But then it's volumetric energy density, it's gravimetric energy density, it's cycle life, it's safety, it's rate capability. A nickel-based technology really has that best combination of all the performance attributes as well as a reasonable cost associated with that.
You mentioned safety. Is there something we need to be concerned about here? Can you please explain a bit further?
No, in terms of safety, so there's, from a fundamental science point of view, there's the thermodynamic stability of the materials themselves. And what that means, because lithium ion is an electrochemical device, it has both voltage and temperature associated with it. And so that sort of equates to the enthalpy or the total energy of the system. So nickel and what's used in cathodes is the oxide of these elements. So it's nickel oxide, cobalt oxide, manganese oxide is what's actually used. And even though nickel oxide has by far the highest energy density, that's why it's required. It also has a lower temperature at which there's a thermal runaway. So there's a temperature associated with the breakdown of the materials themselves in which oxygen is actually released. And so cobalt and manganese and aluminum are used to strengthen the support. It's really more or less a physical thing inside the matrix itself, so that it stabilizes the structure so that it actually can tolerate much higher temperatures and voltages.
Okay, so there's clearly a lot that goes into creating a battery, beyond just really smart people, and some slightly less smart people asking them questions. But with such varied and complex materials at play, it makes you wonder, if electrification is the way to a cleaner future, are the batteries that produce clean power actually clean? In other words, how sustainable are EV batteries? Ken?
First and foremost, 100% of all EV batteries will be recycled. Currently, the value proposition of that is not great because of the efficiencies of actually doing it. A big part of the value is in the elements that make up, again, the cathode. So there's a number of processes. There's hydrometallurgical and pyrometallurgical processes that are being developed to actually recycle the cells back into their pure state of nickel, cobalt, manganese, etc., which then gets fed back into the battery, into new production. But in the next decade, there'll be a lot of processes that will be associated with reducing the cost of that, recycling and also obviously reducing the carbon footprint. So it can be used, and it's really all towards the sustainability of the batteries and EVs as a whole. It doesn't make a whole lot of sense if to drive electric vehicles if you can't dramatically reduce the carbon footprint of this whole industry.
Any last thoughts from you on, where we are with battery research and the nickel and like the importance of rechargeable batteries and nickel's role and all that?
Nickel will play the dominant role in high-end batteries. So the large vehicles that we like here in North America, big powerful engines, they translate to large high energy dense batteries. And so there'll always be a really strong desire for those kind of technologies, and nickel will always play the dominant role. And when I say dominant, it'll be 80 to 90% of the material in the cell itself will be nickel. Having said that, there are other technologies. So LFP, as I mentioned before, it's a much lower cost technology. It has a lot lower energy density, and it has a much lower So that vehicle won't go 500 kilometers, but there will be a market. There is a market for that and will be in the future as well. But high nickel will always be the number one in terms of performance.
So yes, the potential for nickel in EV batteries is incredibly high, but as we just heard, the pursuit of clean energy must be considered within a 360-degree, cradle-to-grave perspective. It's not just about creating a better output, it's about the entire process, the entire footprint. As Ken said, driving electric vehicles just doesn't make sense if they aren't helping to dramatically reduce the carbon footprint across the entire vehicle industry. And while recycling clearly plays a critical role in the EV and battery clean energy story, what else should we be asking ourselves when it comes to our use of battery technologies and nickel? Better yet, what should we be asking Professor David Wilkinson from the Department of Chemical and Biological Engineering at UBC and Canada's Research Chair in Clean Energy? Because he probably knows a bit more than us. Professor, with the global rise of electrification, how do you see EV technologies and nickel demand trending, and what should we be watching out for?
I think in forecasting where, for example, electric vehicles are going, perhaps as much as 75 to 80% of batteries used in electric vehicles by 2030 will have a large amount of nickel in them. But this, on the other hand, creates a very significant issue from a resource point of view. And, nickel is not an abundant element. It's not like sodium, for example, or some of the other earth-abundant elements. In fact, its abundance is actually quite a bit less than lithium, several hundred times less. So also nickel is used in other applications like stainless steel, in chemical industry. So the demand on commodity demand on nickel is going to increase substantially. And, you could see that could create a lot of issues if the mining of it and the extraction of it isn't managed properly. So that's a big worry. I think Elon Musk made a quote about his biggest worry, what prevents him from sleeping at night, is nickel supply.
So if the richest man in the world has a problem that's keeping him up at night, what does he do? He throws some money at it. A lot of money. And while this isn't in itself a bad thing, investment is important and can lead to many advances. The fact is, money can also attract some undesirable qualities. When Elon promised to award a very large contract for a long time to any nickel mine who could meet Tesla's demand for clean nickel, he definitely created some excitement and some concerns. Let's hear from Professor Wilkinson.
The worry is that if the mining is not managed properly, it's going to have a devastating environmental effect. That's a big concern, right?
Yeah.
We have examples, or starting to see examples of offshore sea mining of lithium by mining the ocean floor. And from my point of view, and I think many people would argue the same, that could have a devastating effect on ocean ecosystem, which is not really well understood. And, there wouldn't necessarily be a lot of oversight or regulation of that. So that's a whole new type of mining that could have a devastating impact, on the environment, to mine for lithium, for example. But it could be for mining for other precious metals and other elements as well. Mm-hmm. These, I think, for many countries, these are seen as opportunities, to improve their GDP and bring in revenue, right? But it has to be controlled.
Yeah, we have to keep that in mind. Professor, this was just a fantastic conversation. Thank you very much for your time today. I really appreciate it. Okay, so not everything nickel is necessarily shiny, but that makes sense because the push for global electrification equals big money, and big money often comes with some big concerns, and that can be a big deal. But before getting into all that, let's recap some of the positives. We learned that nickel is the clear preferred choice for EV batteries, outperforming its alternatives on both power and range, all at a very attractive price point. We gained some understanding as to why nickel is in such incredibly high demand, and why that demand is only going to grow. We also learned that EV batteries are 100% recyclable, and that recycling efficiencies are only getting better. All in all, we did some good learning, And what it all points to is potential, a potential that can only be realized if we are careful and do things properly. Clean energy is not a corporate goal, it's a global cause, a necessity for our survival. We can't afford to take shortcuts or let greed muddy the waters. As Professor Wilkinson points out, the overwhelming demand for nickel puts some serious pressure on the mining industry, and if things aren't managed properly, there can be some catastrophic consequences. The responsible and sustainable mining of nickel must be the key to achieving our clean energy goals, which is why we're going to spend more time talking about it. In our next episode, we'll do a deep dive into nickel mining, learn about where it's happening, how it works, and why not all nickel mining is necessarily the same. Thanks for listening to the first episode of the Charge Podcast. Make sure you catch our next episode by subscribing or following our show on Spotify, Apple, or wherever you get your podcasts. For more info, visit thechargepodcast.com or follow us on LinkedIn and at @the_charge_pod on Twitter. And if you feel so inclined, please leave us a review at Apple Podcasts. We'd love to hear from our listeners. The Charge is a Giga Metals podcast produced by Podium Podcast Company.